Thank you, Peter. Thank you all for coming. Welcome to this talk. This is a joint work with my colleagues, Meng-Wang, Dimitris, Mavrokapnidis, Kyriakos, Katsigarakis, Korolija, and Dimitrios, Rovas. We are in the Institute of Environmental Design and Engineering, University College London. Let me carve the big picture. This work belongs to a project, a European research project called DigiBuild, that is related to the development of digital twins for building stock and the development also of services on top of the digital twins. These are the, let's say, the parts of this talk. I will initially introduce the motivating concepts of our work. I will then move to the proposed methodology. I will present an application example, and I will conclude in the end with some conclusions and future work. So let's start with the motivation. So DigiBuild requires the building energy performance simulations to be carried out in order to provide services for the built environment. So these building energy performance simulations require the formation of the HVAC topologies of the buildings. So doing this formation manually from MEP designs, it's an error-prone process and it's a time-consuming process. So essentially what we need is to automate this process and do it semi-automatically or automatically if there are no errors, directly from the BIM data. And of course, it will be better in terms of accessibility to do it from open BIM data in terms of the IFC files. So essentially, in a nutshell, this work is related to this transformation and the formation of the HVAC topology from open BIM data. So to do this, we introduce a three-stage methodology that consists of extraction of data, the second is the checking of data, and the third is the establishment of the topology. So in the extraction, the first stage, the extraction stage, we take input data, we extract input architectural data and MEP data, geometric data, as well as additional semantic relationships from MEP components. In the checking stage, we perform geometric checking in order to generate geometric relationships among the extracted geometric data, and also we perform some checking or some extracted semantic relationships as well. And then in the end, in the establishment stage, we form the topology and then and also the respective knowledge graph. So in the first stage, the extraction stage, we extract geometries of elements, of architectural elements, as well as MEP elements from the architectural IFC and the MEP IFC files. And we use also a dedicated tool to extract this geometries that is called IFC Geometry Exporter of the BIM management platform, which is an existing platform. We also we extract also additional semantic relationships related to the IFC Rail Connect ports relation from the MEP IFC files using the IFC OpenShell tool. So the extracted geometries and then the extracted semantic relationships are passed to the next stage, which is the checking stage. In the checking stage, we use a novel tool called GRC tool, which is able to perform geometric checking among thousands of elements and geometries in a parallel fashion. Using multi-threaded processes, and we detect three types of geometric relationships that are the class relationship, the containment relationship, and the adjacency relationship. In case we have surface errors, we replace the geometries with the oriented bounded boxes to perform the geometric checking. Using the above geometric and semantic related checks, we establish, of course, we use also semantic relation checks from the extracted IFC-RL connect ports relations from the MEP IFC file. Using these relationships, extracted geometric and semantic relationship checks, we induce connectivity pairs between MEP elements and containment pairs between spaces and MEP elements. On the bottom part, you can see a relation between the geometric relationships and the induced semantic relationships. From the left to the right, you can see how an adjacency relationship is used to infer a connectivity relationship. In the same manner, you can see also how a class relationship, geometric relationship, is used to induce a connectivity relationship, and then at the end you see how a containment relationship in geometric terms is used to induce a containment semantic relationship. So, of course, human errors are present, and the human errors render the whole process semi-automated. Using this process, we were able to detect 5 types of errors, which are abnormal class between where we have MEP elements intersect. We have a missing element in a chain of connected MEP elements. We have a classification error where a specific MEP element belongs to a class of MEP elements that it should not belong to. We have a space containment error where an MEP element is not contained in a specific space. So in this case, we cannot detect a space containment relationship. And of course, we have a geometric mismatch where 2 neighbor or adjacent MEP elements are misaligned. And in fact, they are not adjacent in geometric terms, but they are close to each other. So in the third stage, we have a final establishment of the topology using the containment pairs and the connectivity pairs that are reduced from the second stage. So we form a knowledge graph that captures these containment and connection relationships, and also using real estate core and brick ontologies. So in a nutshell, we have architectural elements, which are spaces, MEP elements, ducts, terminals, and systems, and all these things are used in order to form the final knowledge graph. So let me move to an application example. We applied this methodology on the UCL, so on the One Pole Street building of UCL. And also, since this is a huge building that consists of 2 towers and a podium, we applied only on the podium of this building to test the whole methodology. The podium also, as you can see on the right side, from top to the bottom, you see the space topology of this podium, which consists of 167 space volumes, space geometries. And as far as the MEP data are concerned, we have approximately 8,700 air loop elements and 20,800 water loop elements. So we have a lot of geometries that we need to process. So these are some results. On the 2 pie charts that you see on the left, you see our success related to the containment relationships that are detected for air terminals, and the connectivity on the bottom, the connectivity relationships that are detected for also these terminals. So containment in terms of the spaces that these terminals belong to, and connectivity in terms of the systems that are serving these terminals. So we can see that approximately 70% are connectivity relationships are detected correctly, whereas approximately 10% and 10% we have no containment relation, and there are also some errors related to design errors where a terminal is contained in 2 or 3 spaces. The same results on the bottom chart. You can see how the connectivity of the terminals is detected. Of their terminals, we see approximately 90% are detected correctly, where like a few, like 1 or 2%, are not connected to any system, or there are cases also we have terminals that are connected to 2 or 3 systems, which is an error due to an incorrect design. In the middle, you see a snapshot of the graph that is formed for the room 101, and you see with different colors the established connections among valve boxes, air terminals, chill water pumps, and rooms and hot water pumps. So, and of course, on the right, you see the classes, the FC classes that we used to extract geometries and relationships, and also the respective classes from the brick schema ontology that we used. So let me conclude. So in DigiBuild, we need building energy performance simulations, and to facilitate the generation of building energy performance simulation models, we introduce a 3-stage BIM to HVAC topology generation process. The introduced workflow uses as input architectural as well as MEP geometric data and existing semantic relationships. We use tools, geometric tools such as GRC and oriented bounded boxes to extract the certain geometric relationships among these elements, such as class, adjacency, and containment, and to induce from these relationships semantic relationships related to connectivity and containment. So the induced semantic relationships are used in order to form the final HVAC topology and the respective knowledge graphs using REC and brick ontologies. So this is an initial phase, beta testing phase. We test the workflow, and we are planning in the future to include this workflow in the BIM management platform environment that is already developed and uses an advanced GUI for better user-to-machine interaction. Thank you very much.